Good morning. The bibliographic references and the publisher's source article are accessible in the description under the video. If you want to support the dissemination of scientific knowledge, subscribe. And can you give it a thumbs up, please? Tenderness is the major criterion driving consumers' decisions to purchase meat. A means of controlling and assuring a meat product's safety and tenderness level is essential. Unfortunately, tenderness has proven to be the most difficult quality factor for meat producers and meat packers to manage. Thus, a commercial method to ensure a consistently tender meat product is of primary importance for enhanced consumer acceptance of meat. Techniques applied individually or in combination include mechanical, chemical, temperature conditioning, aging, electrical stimulation, high-pressure heat treatments, and alternative carcass positioning. A number of these techniques require additional holding periods, space, and labor. Furthermore, several of these methods have been criticized for their lack of consistency in tenderizing meat. The concept of tenderizing meat using shock waves from underwater detonation of explosives, called hydrodynamic pressure processing, was first patented by Godfrey. Hydrodynamics refers to the motion of fluids and the forces acting on solid bodies immersed in these fluids. The hydrodynamic pressure processing process should not be confused with research using high hydrostatic pressure, which was introduced by Japanese scientists and dates back to the end of the 19th century. The hydrodynamic pressure processing treated meat displayed no outward signs of change, but on cooking, it was found to be significantly tender than non-treated control samples. Hydrodynamic pressure processing involves underwater detonation of a high-energy explosive in a containment vessel to generate a shock wave pressure front at velocities exceeding the speed of sound. The shock wave passes through the liquid medium and vacuum packaged meat placed at the bottom of the container. Shock waves generated and transmitted through water move equidistant from an explosive source depending on the shape of the explosive. The shock wave, with targeted pressure fronts of 70 megapascal to 100 megapascal in the hydrodynamic pressure processing process, occurs in fractions of milliseconds. Eugonate adiabatic compression of water or of aqueous solutions causes a temperature increase of only 2 to 3 degrees C per 100 megapascal, depending on the initial temperature and the rate of pressure increase. Pressure release causes a decrease in temperature of the same order of magnitude. Because the dynamics of shock wave pressure front in the hydrodynamic pressure processing process occur in fractions of milliseconds and at pressures less than 100 megapascal, there is virtually no increase in the temperature of the meat or water. The shelf life of hydrodynamic pressure processing treated meat product is increased by reducing the non-pathogenic normal microbial flora in the sample. Microbial populations of hydrodynamic pressure processing treated meat does not increase significantly for approximately 14 to 15 days of storage at 5 degrees C, whereas there is increase in microbial population of untreated meat products. Conclusion: meat is an important component of a healthy and balanced diet due to its nutritional richness. The composition of meat provides an ideal environment for the growth and propagation of spoilage microbes and common foodborne pathogens. Microbial growth and metabolism depends upon the condition of the carcasses at the time of slaughter, the type of packaging and storage conditions. Microbial spoilage results in a sour taste, off flavors, discoloration, gas production, pH change, slime formation, structural components degradation, off-odors and change in appearance. Preservation ensures that the quality, nutritive value and edibility of meat remain intact. It may be noted that modern meat food processors do not rely on any single preservative technique. For controlling enzymatic, oxidative and microbial spoilage, low-temperature storage and chemical techniques are the most common in the industry today. It is essential to store the meat at lower than 4 degrees C immediately after slaughtering and during transport and storage, as it is critical for meat hygiene, safety, shelf life, appearance and eating quality. Therefore, it is imperative to employ a combination of preservative factor in a balanced manner to derive maximum benefit. A combination of chemical additives such as tertiary butyl hydroxyquinine and ascorbic acid can be most effective for controlling spoilage of meat and meat products. The application of pressure processed meat or meat products will be launched in the market in the near future because of the development of true commercial scale high pressure machines and reduced running costs. As meat is quickly spoiled due to microbes, it is advised that meat should be properly preserved so that it remains in good condition for future use. Further work on the development of low cost-effective preservation technique without affecting organoleptic and nutritive qualities of food, which can be easily practiced by poor resource nations of the world, will be rewarding